Wow, somebody liked the video. How kind of them. Well, hello, two of you. I hope it's two of my students. Are you able to comment? Are you able to type anything in the comments down there? Or are you just letting your computer sit? That is also possible. Well, I will just sit here. Oh, I know what I can use. Stool will hold my whiteboard. I need something to hold my board. It's my actual work. It's not ideal because of the shape of the chair. Hey, okay, good. So Drew, it's working for you. You're able to type. That is exactly what I wanted. Can you please tell me if the words are correct? Because on my screen, they're all flip-flopped, but it should be working on yours. Oh, so Drew, you're using a private account. Well, that's annoying. Student that just texted me, I'm not going to say your name, or rather commented, but I told them to allow them, and of course they didn't, because that would be too easy. So if you're using a private account, I guess it lets you comment, and if you're not, it doesn't. So here's the thing. So Drew, you're saying these are correct. Like you can read the words. I'm gonna wait. I'm not gonna say anything else. You're on your school email? Well, that's interesting. Other student. Okay, good. Thank you. So other student who I'm just gonna say is initials KE. Um, if he's able to use his school email, then hopefully you can. But otherwise, that's why I put the remind information up here, so you guys can text me during the stream and ask me any questions that you have on there. I was really hoping the chat would work because then I've got everything the way I want it. If you can't stop coughing, you're gonna go in another room because everyone on here is gonna think you have corona. I don't know. You didn't drink your water the wrong way. All right. So anyway, we're all good over here in the Naren household. She swallowed the wrong way. You guys know how it is. Who was I talking to that said that happened to them? It wasn't me. No. There was somebody that said was it Luke? But one of my friends said, yeah, I was at the store and he said, and I just swallowed my drink the wrong way and I kept coughing and everybody thought I had corona and I just told them, no, I swallowed the wrong way. So anyway, corona's not anything to joke about. Well, there's three of you. We're a little early on the stream. I just wanted to get on here and make sure everything was working all right. We'll start probably right on the dot at 4:30. But if you guys have any questions for me, I am here to answer your questions. Both on my phone. KE, if you would check, you should be able to sign into YouTube or at least sign into your Google Chrome browser using your student email. Oh no, Drew, am I going to get demonetized? Well, it's a good thing this stream is brought to you by Raid Shadow Legends. With over 1 million active players and thousands of collectible characters. Honey. No, and I should be using Honey. That's right. This is actually sponsored by the Honey browser and audible.com and NordVPN. So we're good. I got to get all my YouTube sponsorships covered. Got to get all the YouTube sponsorships covered. But I'm hoping this is going to be easier for people to access. It'll save the stream when I'm done with it, so people that wanted to watch it at 9 o'clock in the morning for some reason can go in at 9 o'clock and it'll still be saved. So hopefully this will work out. Well, everybody in the comments, you doing okay? Yay, you did it, Caitlin. What is my Fortnite creator code? I have no idea what that means. I have never played Fortnite. Remember, Minecraft. That's me, Minecraft. I'm going to end this stream and immediately go to a Minecraft stream. We're going to talk about the new Nether update and the new ore that's apparently purple. I saw it in my news earlier. I can't remember what it was called. It started with a P. I can't find it now. I'm going to check on something real quick while we're waiting to get things going. Let me get my pile of markers ready. Got my reference table. No, it's not netherite. It was something else. Doesn't matter. I mean, it's not going to help you with moles to mass, but still. So let's see. Buncombe County is drafting a stay home, stay safe order, aka shelter in place. So, guys, we got about 6 or 7 minutes. I'm just waiting for everybody I'm giving them a chance to join. If you know of anybody that wanted to see the stream, tell them we're on here. We're hanging out. In fact, I can use Remind. Isn't technology wonderful? All right. Ty, thanks for joining us. We got 8 people and 3 likes for some reason. I don't know why you guys are liking this video. I haven't said it yet. Like, comment, and subscribe, even though you can't subscribe because you're on a restricted account. Oh. 9 people. Wow, I can barely contain my excitement. Hello. Ten people. Wow. If we can get 20 people, I will be so happy. Yes, this is live, Sydney. I'm watching you type that. Hold on, what does this mean? Drew, I don't know what that means. There will be no cyberbullying. I specifically told the tech person, I said, I'm going to carefully monitor cyberbullying. It didn't work. Okay. I thought you were going to do like an infinity gauntlet type thing, but I wasn't sure. Oh, really? Well, hello, Gannon. Through the internet. What are you trying to do, Drew? Drew, who's controlling like 60% of the comments right now. Yeah, probably. Okay. I'll pretend like I know what that means. Now, who is... All right, guys. Who is pro Stowe? Before I mute them in the comments. How do I do that? Let's see. 3 dots. And I can do remove, hide user, report. Pro Stowe, you better stick up for yourself before I kick you out. Yeah, it's tough, Tess. It's tough. And the rain isn't helping. But sun's coming out tomorrow. Should be. Hello, Ashley. Welcome to the stream. We got 14 people. Can we get it to 20 people? Because that would just be fantastic. Had people emailing all day asking for this, and then they don't show up to the stream. Got 2 minutes. We're going to get started in 2 minutes with our scheduled programming. I was just watching an exploit video on that. I think it's Tanner. On Animal Crossing. It's the cardboard box spin exploit. And you put an item on top of the cardboard box, and then you have a friend spin the box, or sorry, spin the box, and in mid-spin, you pick it up. Hey, Gannon, thanks for joining. This isn't even a class you're in. But, Tanner, get on it. Find the exploit glitch for Animal Crossing. Hey, Tony. I miss all of you, too. This is killing me. Howdy, Austin. Thank you. Um, who is that just joined and is calling out the other spam bot? Drew, who can't join? I am not joining your Minecraft. If I played Minecraft during school hours, I would get fired. If I played Minecraft with students, I would get fired. Who am I kidding? Drew, who can't join? Ooh, what does this do? Drew, it might actually be illegal. Well, and not, if it's not illegal, it would be certainly frowned upon by school officials. All right, guys, it's 4:31. We're going to go and get started. If you know of anybody that wants to join, yeah, right. I do have good lighting. I'm very proud of my lighting, the spotlight I have. All right, so we're going to go ahead and get started. If you guys see anything weird going on in the comments, for instance, Pro Stowe from earlier, I deleted the message and put them in timeout. And then we also have, I don't really want to repeat it, but Diddley Fiddler. Okay, you're going to be in timeout if you don't identify yourself, because I don't know. I didn't know bots were going to be such an issue. But anyway, we're here. We're ready. So welcome to Chem Chat. And I've been told that you guys can read this, even though on my screen it's flipped the wrong way. Just want to go over some general stuff before we get started with the questions I know you all have. I'm going to go quick. First thing, this is the biggest issue that all the students in my class are having trouble with. You're not reading everything. I put very specific instructions for a reason in all of my Google Classroom posts, and then I post the exact same information on OneNote every single day. And those of you that are asking me questions, 50% of the time, it's just you saying, oh, I can't find such and such. It's there. You didn't read it. Oh, how are we supposed to send you? What if we write it on paper? What do I do? Don't email it to me. I told you guys, I said you post it at the bottom of that page. So reading everything is crucial. And going back to the handwritten thing, it's really not that complicated. You guys we're going to go over a lot of stuff. Allie, you should be able to see it in the description. We're going to get started in a second. I just want to do announcements. So if you do have some handwritten work and you want to turn that in, you need to go to the OneNote page. For instance, the quiz yesterday, which was called Chemical Equations, I think is what it was called. If you wrote your notes, insert the image at the bottom of that OneNote page. The reason I need y'all to do that is that makes it a lot better for me to keep everything organized, to keep everything accounted for, in case something happens. And I'm going to talk about that here in a minute. So just make sure you're following the instructions. Read everything, okay? If you have a question, go back and double check and make sure you read it correctly. Do not procrastinate. I would say right now, about 50% of you are doing exactly what you're supposed to do. Like you're on time, you're doing what you're supposed to for that day, and you're on top of it. The rest of you, I don't know what you think is going to happen, but Cooper announced yesterday we're going to be out of school until May 15th. So if you just had in your mind, oh, well, this is probably the last week and then we'll be back. No, we're not. Okay, so you have got to be doing stuff if you want to get credit for the class. Communicate. Another issue I'm having with a lot of students is it's like you don't find something and then you're like, oh, well, it's not there. I guess I won't do it. No, if you are having issues, you have got to communicate with me. I've got both remind codes on here. So if you're watching the stream and for whatever reason you're not able to comment, you can send that to me. Okay, you can send me a remind text. I get back to you as quick as I can. A lot of you are emailing me. That's fine. If you need to email me, I'll get back to you as quick as I can. I've noticed a little bit of delay on both, And I think that's just because of the amount of traffic right now of, everybody's trying to communicate digitally, but I will get it. I will get back to you. Okay. So communicate. Do you know where to find everything? We went over this before we went digital in the classroom. And I said, look, where are the notes every day? And everybody said, oh, it's in the NARN folder. That's my folder under the unit. That's right. You should have found notes today on the mole, and you just copy them into your notebook. And if you have questions, that's what this is for. We're going to go over that in a second. Green sheet. A lot of people have been saying, like, how am I supposed to do predicting products if I don't have the green sheet? You do. It's in your folder, your general folder, and it's even called green sheet. Now, I printed one out for myself for convenience. So I have one printed out. If you have that ability, great. If you don't, you still have the same information as everyone else. Worksheets. If there is something that you need to complete, it will be in your folder. Even the quiz yesterday, I put it in your folder. So you have everything. And finally, the last thing I want to talk about before we get down to the actual nitty gritty is the end of school. I had a student yesterday, because we did this for AP chemistry, and they just blatantly asked me, it was like, hey, what do you think is going to happen? I don't know what's going to happen. Nothing like this has happened in, modern history, where the whole globe is kind of having to shut down and everybody has to relax. It is my guess that we may not be back. So right now, they're saying May 15th, we'll be back in school. Maybe. Even Cooper, I think, in his message, I didn't read it. I read the press briefing, but yeah, we are a part of history. And so based on the press briefing, it made it sound like Cooper was saying, yeah, at least until May 15th. And honestly, guys, I don't think we'll be coming back. Okay. So here's the thing about exams. If you have been reading the news, another thing they talked about yesterday is the General Assembly passed an exemption that basically means, in common language, we're not going to have final exams. If you have an AP class, you can talk to specific AP teachers about that. Brianna, I'll talk about seniors in a second. AP classes, they're still going to have an exam, but it's going to be a at-home, on the computer exam, which is not ideal, but it's better than nothing. As far as seniors go, that's something that Cooper's talked about. He said, look, not just Cooper, but Mark Johnson, my favorite person. Okay, all hail our glorious NC school superintendent. But he even said seniors are a big concern, and trying to get back in school at least so we can have a little bit of time, so we can still have graduation. But the thing is, they don't make those decisions. The CDC and the North Carolina Health and Human Services Department, they're the ones that are making those decisions. So schools are just having to do what we can. And pretty soon schools may have to become, I don't want to use the word shelters, but they've talked about using public schools as a way to get services out to people. So if people are needing to do food, they've already been doing food delivery. If you need food, email me personally and say, hey, I know someone that's really hungry right now. We need to get them some food. Communicate to me personally via email, and I'll make sure that happens. But they're talking about using schools for that. So here's the important thing for us. You're going to say, well, Mr. Nairn, if we don't have final exams, why are we even doing anything? So the word that got thrown around recently that piqued my interest is the word mastery. They use that word and emphasize it in a school email. Basically, in certain classes, you can be exempt from exams as long as there is demonstrated mastery, which basically means as long as you have artifacts or you have evidence that students are doing the work, they understand it, in documents, like in physical worksheets, like the quiz. If you guys are doing that, that's how you could get credit. So if you know of someone, and I know of several that I've been trying to get in touch with, and they're just ignoring me. If you know of someone that's not doing any work, they may not pass the class because you're not doing what you're supposed to. I put in incompletes in Power School. Those can change. As soon as you complete work, you email me and say, hey, I did chemical reactions worksheet. Great. I'll go back in and look at it. We're not naming any names here, guys. We're not naming any names here. Don't get put in timeout, but yeah. Content through demonstrated mastery just means do the things I'm giving you. It is in your best interest, and stay on top of it. Okay. So no final exams. You're still going to get some type of credit. Demonstrated mastery is something to think about, which basically just means if I give you an assignment, you better do it. And the last thing that I'll mention, is your last 9 weeks is really important too. So if for whatever reason you didn't pass the last 9 weeks, You better really be taking this 9 weeks seriously. Okay. All right. Are there any questions? I'm going to take a sip of tea. Are there any questions before we get down to work? We're going to start by going over the quiz, I think, quickly. Yes, F and chat for all the people that failed the first 9 weeks. I'm so glad I understand most of y'all's memes. I may pretend like I don't get them, but I usually get them. All right, no questions? There's a little bit of a delay. That's why I'm going to take an awkward pause because it's like a 5-second delay. Is that how much it was? Yeah. So we have a 5-second delay. What is? I can't see it. Okay. All right, let's get to work because I'm losing people. I can see up there we were up to 19. We didn't hit 20. Oh, we're back to 18. But I don't want to lose people because they're getting bored of our chatter. Okay, don't worry, Austin. I'm going to go over that. But first, I want to talk about the quiz. So first thing I want to talk about is that quiz. A lot of people, I don't know, seem kind of confused by it, and you shouldn't be. If you have access to the green sheet, which you do, everything should be pretty easy. So if you don't already, go ahead and have your Unit 4 equations quiz out in front of you, and we're just going to talk it over real quick. This is a good way for you to make sure you have the correct answers before I go ahead and start grading it. No, my wife is not going to teach. She is going. Shh, no, you cannot. You're coughing, remember? No. Shh. She's not sick. She's great. But no, she's probably not going to help teach instead, Brianna. But if you guys don't get it after this, maybe I'll put her on. All right. So let's go ahead and talk about that quiz. Number one, had a pretty simple reaction on number one. We can see that you start with Na plus aluminum bromide, and then it becomes sodium bromide plus aluminum. Obviously, that's a single replacement. But just like on the predicting products worksheet, a lot of y'all had the same issue where you would say single replacement. Yep, that's it. I'm done. No, there are so many specific types of single replacement reactions. You can't just stop at single replacement. So if you're doing it correctly, you should have said single replacement type A. Okay, single replacement type A. Because as we can see on here, that is a metal to metal replacement. So sodium is replacing aluminum. So don't just stop at single replacement and think you're done. You've got to tell me the specific type. Okay. Next, let's look at number 2 on the quiz. Moving kind of quick. You guys say in the comments if you actually have a question. The next one, we have HCl plus NaOH. Now, this was one of the things I told y'all to look for. In fact, in the last stream that a lot of people joined and some of you didn't, we talked about this a little bit, this specific type of reaction. Now, obviously, we know this is going to be double replacement. The reason we know is we have 1, 2, 3, 4, like different things. We have 3 different elements, 1, 2, 3, and we have 1 polyatomic ion. But whenever you have 4 things, you just know it's going to be a double replacement. But you need to know the specific type. So this is where this comes in. And we haven't talked about acids and bases yet, but this is an acid-base neutralization because look, if you have an H out front, that is a huge red flag. Okay, here, I'll even draw it. That is a huge red flag that this is an acid. Okay, acids always have that H out front. Okay, if I do grading, yeah, I'm going to put the grade like on your quiz. It'll be on the OneNote page. So if you inserted an image like I told you to, I'll just write on the image and put your grade on there. Next, we have NaOH. And another thing to look for is the OH. And this was in your notes for double replacement. But if you see OH, that means it is a base. Okay, that means it's a base. So this would be sodium hydroxide, but it's still a base because it has OH at the end. This is an acid. It has an H up front. This is hydrochloric acid. It is the most well-known of all the acids. So this is going to be a double rep type B. Okay, this is going to be a double rep type B. Is it okay if you just put metal, metal? I mean, you could. I just think it's better just to say single rep type A, double rep type B, just to keep it concise. Okay, so number 3, quickly moving. We're moving. Number 3. CH4 plus O2. Guys, what is CH? Hopefully you're all saying right now. hydrocarbon, okay? If you have a C and an H, it's a hydrocarbon. If you have oxygen, that's something you need for burning as well. You get CO2, you get water. All those things are letting us know that number 3 is definitely going to be a combustion reaction. It's definitely going to be combustion, okay? Let's take a look at number 4. Let's take a look at number 4 as I adjust the camera just slightly. Just slightly. There we go. So taking a look at number 4, on our worksheet, okay, on our chemical equations quiz that you all need help with. Yes, exactly, Tony, combustion. We have MgO, that's magnesium oxide, plus H2O. So water is something else that shows up quite a lot. So even though some of you guys might be looking at this and saying, oh, we have 4 things, not on the other side you don't. You have 2 separate things that combine into one compound. So we know this is going to be synthesis. But as you can see on your equation sheet, there are lots of different types. And it just so happens metal oxide and water is one of them. So we know this is going to be a synthesis type B. Okay, this is going to be a synthesis type B. And then we get to number 5. Okay, number 5, we have H2O becomes H2 plus O2. Wow, we started with one thing, now it is 2 things. So that's going to be decomposition. Okay, definitely going to be decomposition, but it has to specifically be Prosto. I don't know who you are, and you had a questionable comment earlier, and so I didn't know who you were, so I muted you. Okay, well, that would still be a combustion in it. Gasoline, like if you look at the formula, it's got a lot of carbon and hydrogen in it. It's a hydrocarbon. So we're going to still call that combustion because you're consuming the gasoline and you're producing carbon dioxide and water. So number 5, it's going to be decomp, and it's going to be a decomp type A. You start with one thing, it separates into 2 separate, just individual elements. So that's all that one is, binary compound. Okay. All right. So that was a good question. All right. Let's take a look at the next ones. Okay. Can I put a poll in here? That would be so helpful. Couple timestamp pop-out chat. No, darn, I don't have the subscriber count to do what I want to do, which is a live poll. You guys say yes if you want me to go through 6 through 10. If you want to go over 6 through 10, you need to put a yes or put an N for no. If you want me to go over 6 through 10 on the chemical equations. Okay. Yes for going over 6 through 10. No for going over 6 through 10. Just a Y or an N. We're going to do a quick poll. Go fast. Gannon, you are not even in this class. You can vote 1 time. All right. Okay. Gannon, you don't count. You're not in my class. I'm going to go quick. So taking a look at number 6. This one's really not that bad. And guys, I don't mean to pick on any of you, especially not if you're saying yes right now. But if you don't know how to do these yet, you better get with it. So we have a not too complicated reaction here. I'm running out of room because I wrote too big. Hopefully you know this is a single replacement type reaction, although that's not what they're asking for. But one thing that a lot of you guys did on the worksheet, hush Drew, one thing that you guys did on the worksheet is you wouldn't do your list. So like on the predicting products worksheet, on the chemical reactions worksheet, you have got to make your list or I'm not going to give you full credit. So you need to go in and say, I have Al, I have Na, I have Br. You've got to do that. Okay. So don't not do it. Let's get the light. There we go. So now that I got all this, I'm sure you all miss counting this off with me in class. And you guys were so good at it. But now that I've got everything set up, we're going to balance very, very quickly. Well, don't write. I was trying not to. All right. This little dinky whiteboard is barely sufficient. So the first thing that I see that is kind of an issue is I got 3 bromine over here. I only have 1 over there. Not a huge issue. I go in here and put a 3. But remember, when you are balancing, this coefficient does not just change bromine. Because I know what you want to do. You want to just change bromine and be like, all right, well, that's 3. So I'm good. But you have to do sodium as well. So 3 times 1 is going to give us 3. Sodium's messed up, but it's not a disaster because I can go over here and put a 3. 3 times the 1, remember there's a 1 right there, is going to end up giving you a 3 as well. All right, so it does end up working. And by the way, Perugini made this quiz. One of the things that irritated me is they said put a 1 if there's a blank. We would never do that anywhere else, but I put it on my key that way because that's what the instructions said. 3131 is what the worksheet wants you to do. But honestly, that's what I would do anywhere else because you don't ever put the 1. We know it's there. We don't need to write it. All right, moving on to number. I'm not doing number 7. Sorry, y'all are gonna have to deal. Why would I not do number 7? Type in the comments. Why am I skipping number 7? Other than the fact I don't want to. Ooh, that's gonna be out of order. Y'all are gonna get triggered. Okay. Yeah, it's good. It's already balanced. Okay. Yeah, and nobody likes number 7. But if we look at number 7, we'll see it's already balanced. So I'm moving on to number 8. Once again, we still have to make a count. We still have to make a list. We have C, H, and O, like we always do in this type of reaction, which hopefully you guys know is combustion. It's not too difficult. So we have a 1 and a 1. We have a 4 and a 2. And we have a 2 and a 1, 3. Just testing it. All right, so now that we have all this stuff taken care of, H is the first thing I want to fix. I've got 4 over here and only 2 over there. So once again, I'll go over here and put a 2. 2 times 2 gives me 4, but it also changed my oxygen. So what I need to say is, oh, well, 2 times 1 gives me 2, plus the 2 that we have right here from CO2 gives me 4 total. So now it's even, which is great. The only other thing we have to do is if I have 4 over here and only 2, putting a 2 right there, 2 times 2 gives me 4. Wow, what a great 4 I just wrote. All right, so there we go. It works out. It's balanced, okay? Number 9, I'm not going to go over that either. Why not? Write in the comments, why am I not going over number 9? Gannon is one of my previous students and will be one of my future students eventually. Yes, Ty, it's already good. Number 9 is good, so we're not doing it. But number 10 we'll look at real quick. It's pretty easy. Blank H2O ends up becoming blank. Wow, I've balanced this one probably 10,000 times in this class alone. So we can see we've only got H and O, which is slightly inappropriate, but we're going to fix it. We have 2 H's, 2 H's, 1 and 2. And so obviously then we're going to want to start by putting a 2 right here. 2 times 2 gives me 4. 2 times 1 gives me 2. So 2 and 2, we're good. Okay, oxygen's taken care of. But then we've got to look at hydrogen. So putting a 2 there, 2 times 2 gives me 4. All right, moving on a little bit more quickly. Now comes the part that so many students are struggling with for some reason, and that's problem number 11. Okay, so let's take a look at problem number 11. For all of these, okay, guys, don't spam the comments with off-topic stuff. It is good to see you, Eli, even though it's digitally. All right, so let's take a look at number 11. For all of these problems, it says complete the following chemical equations by predicting the products of each, and you don't even have to balance them. All you have to do is look at the expected products. And what I've tried to tell you guys is that when you're doing these types of problems, you need to think about it like a recipe, okay? Just like sometimes I look through my kitchen and be like, all right, ooh, that was way too big. Sometimes I look through my kitchen and be like, all right, what do I have to cook with? Well, every problem is giving you specific stuff that you have to figure out, okay, what do I need to use this in? And that's when your green sheet comes in handy, because by looking at the green sheet, well, I still wrote it way too big. And we're not balancing, so why do I keep doing that? When you look on the green sheet, it tells you specifically what you need to have and what you're going to get. So in this case, by looking at it, I can say, all right, well, I've got NaOH, I have FeNO3. Once again, when we have 4 different things, 1, 2, I'm counting OH as 1, 3, 4, I'm counting nitrate as 1, 4 different things, we know it's going to be double replacement. And so what that means is sodium is currently bonded with OH. So it's not going to bond with OH again, and sodium's also not going to bond with iron. The reason why, iron, it's always a cation, has a positive charge. Sodium, it's a cation. It always has a positive 1 charge. 2 positives are not going to bond, so we know that sodium then is going to bond with the other thing, which is this NO3 over here on the side. So what I'm going to do is every time you are predicting products, in this case it's just double replacement, so we're going to switch both things. Na is now going to bond with NO3. Fe is now going to bond with OH. But every time you combine on the other side, you have got to swap and drop again to make sure you get it right. So charge on Na is going to be a +1. If you don't know why, well, this is why. Okay, hopefully you guys remember the +1. Wow, that is really bad. There we go. +1, +2, skip a few. +3, plus or minus 4, -3, -2, -1. So those are just, that's always going to be +1. NO3, we also know from the reference table. As I go on here, I find my list of polyatomic ions, okay? And I find that NO3 has a -1 charge. So swap and drop, one goes down there, one goes down there. We just end up getting NaNO3. And we don't write the ones because we don't have to, okay? So I'm not going to write them. All right, the other thing that we're going to bond is going to be iron. Now, this one's a little bit tricky because if I ask you guys in the comments right now, the sheet is not green. See, Kevin, be sure to watch the replay tomorrow. It's not green because I printed it at home and I don't have green paper. All right, iron is a little bit different. This has a -1 charge up here. This is when you have to do multiply down, divide up, because we don't know what the charge on iron is. Sodium, I just told you, is +1. It's always +1. Iron, we don't know for sure. So I'm going to do multiply down. 1 times 3 gives me 3. Carry it over. 3 divided by 1, because there's a 1 there, ends up giving us 3. So what that means then is I'm going to do Fe plus 3, and I'm now going to swap and drop with OH. Okay, so OH has a -1 charge. I get that from the green sheet. 3 goes down there, 1 goes down there. We get Fe with a 1, which we don't write, and we get OH3, but you need to use parentheses. I want to have 3 hydroxides, okay? I will always multiply down and divide up if necessary. The only reason you do it, okay, the reason you do it is when you have transition metals. Iron is a transition metal. I don't know the charge, so I have to use the charge that I do know, which is the charge for nitrate, to multiply down, divide up to find out what the charge was going to be. And then I just say, oh, well, if this is a +3 iron, I better use it down here. And the reason I know it's +3, even though I didn't write it, is iron is always going to be positive. Metals are always going to be positive. So I can write that over here on the other side. I know I ran out of room. This would be plus FeOH3 over here on that side. And that's all you had to do. I did identify on my worksheet that it is going to be a decomp type A. Yeah, I'm sorry, double replacement type A. But, you know, I didn't ask for that. All you had to do is predict products. Moving on to the next one very quickly. Number 12 is really not that bad. You start with 2 separate things. They're probably going to combine into one thing. So if I start with Be, beryllium, and I'm combining this with O2, I just look at my list. Again, think about it like a recipe book, okay? Well, subscripts don't tell you what to swap and drop, Tony. That's why we had to find out what the charge was. We had to do multiply down, divide up to find out what the charge on iron was, okay? If we get another one, we'll look at it again. But basically, when you're swapping and dropping, you got to know the charges. And if you don't, that's the only time you do multiply down, divide up. So we got Be, we got O2. So if I look at my list, okay, think about it like a recipe list. And I say, oh, well, what thing starts with 2 and becomes 1? Oh, synthesis type A. Because synthesis type A says you have an A plus B becomes AB. That's exactly what we're dealing with here. But again, do not just say, well, that's a 2 and that's a 1, so I guess it just becomes BeO2. It's not, because you have to swap and drop. So what I'm going to do, because when you recombine, you always have to swap and drop. So Be, okay, I can look on my sheet. I can find out, oh, it has a +2 charge all the time. Beryllium is not a transition metal. It's always going to have a +2. Oxygen is always going to have a -2. So when we swap and drop, the 2's come down. But as you guys know, we would not write Be2O2. We simplify it. And so the 2's just go away and we get BeO. And so that's what we get up here. Predicting products is not that bad. It's just how well can you use your recipe book over here to find out the correct type. Okay, let's take a look at number 13. Rather quickly. Number 13, no, I do want to go over number 13. This is a double replacement acid-base problem. So this one's a little bit weird, but you guys can still do it. Okay, number 13. So this is going to be double replacement type B. I know I didn't ask for it. I'm just writing it down. Okay. And so what I look at is I say, well, I've got KOH. By the way, you guys type in the comments, KOH, what is that going to be, an acid or a base? You type in the comments. Ooh, that was bad. There we go. I'm waiting on y'all's comments. What is KOH? Wow, y'all are all over the place, and one of you is not even in my class. Guys, if you have an OH on the back, it is a base. It is a base. If you have an H out front, it's an acid. In fact, you guys should know this acid because it's one of the 4 that I told you to memorize. Gold star to whoever tells me what acid this is. That was a weird autocorrect there, Gannon, to go from acid to base or base to acid. But gold star to whoever can tell me what that acid is. But anyway, because this is a double rep type B, acid-base neutralization is always going to give you 2 things. Let me scoot my whiteboard a little bit closer. So it's going to give you 2 things. It is going to give you a salt, not a salt, okay? Salt and water. It's always going to be that. Now, salt, as I've mentioned before in class, good job, Drew, phosphoric acid, is just going to be an ionic compound. That's all it is. A salt is just an ionic compound. And so in this case, let's look at what we got. Here's our water here and here. Because when you have H plus OH, we never write it as this because, as I've said, that's a little inappropriate unless you say it 3 times. So we're never going to write it like that. We're always going to rewrite it as H2O. So we know there's our H2O. So let's look at what's left. After you deal with the water, look at what's left. Yes, gold star for Drew. Look, K and PO4. So that's going to be our salt ingredients right there. So when we swap and drop, and I'm going to do it up here, okay, we can see that K has a +1 charge. Just by looking at your reference table, we know +1 is written at the top of group 1, which is what potassium's in. And then we have PO4, which is a -3 charge. So when we swap and drop, the 3 comes down there, the 1 goes down there, so we're not going to end up writing it. So we end up getting K3PO4, which, by the way, would be potassium phosphate. Okay, so there we go. There's number 13. Not too bad. And now we're moving on to 14. And guys, I promise you, 15 through 20 are really important because I have gotten a lot of texts. If you want to get this, you can pause the video later. But I've gotten a lot of texts from people saying, can you go over predicting, solubility? Can you go over activity series? It's really not that bad. Remember, you only use activity series, that is like, does a reaction happen at all? You only use that with single replacement reactions, okay? And then you only use solubility rules with double replacement. But anyway, we got one more of these. 14. It's not that bad. It's just a single replacement. And this is a single rep type A. Okay, single rep type A. And so I have Al2, SO4 with a something, probably a 3. Yeah. Plus Li. The reason I know this is single replacement is, look, we have 1, 2, 3 different things. Aluminum, it's a metal. Sulfate, that's a polyatomic ion. Lithium, that's a metal. So we have 3 different entities. So I know something's going to swap. And you don't have to do activity series here. I promise if you look on the activity series, lithium will push out aluminum. But we know that lithium is going to replace aluminum. So that means that lithium is now going to bond with sulfate. But once again, even though there's a 3 right there right now, it doesn't mean that there's going to be a 3 when you combine these 2. Charge on lithium, it's going to be a +1. Charge on sulfate, it's going to be a -2. Sorry, I had to cheat. So the 2 is going to go down there. The 1 is going to go down there. And so we end up getting Li2, SO4. And I'm not going to write the 1. I know it's there. Okay. So we end up getting Li2, SO4 plus, can't forget aluminum. It didn't just disappear. It's just all by itself now. Okay. It's all by itself. All right. So that's all. That's all we have to do there. All right, let's take a look at number 15. So as I'm erasing, I'll try and read the instructions. So what it says, based on activity series, determine if the following single replacement reactions will occur. You are just trying to determine, are they going to happen at all? And guys, when you're dealing with your activity series, you've got to remember this. Above will shove. Trademark Morgan Nairn, because she's over here going, that's such a good idea. But yeah, there we go. Above will shove. Okay, it's important. So as we're looking at all of these, all right, just keep that in mind. All right, starting with number 15. And basically what we see is we see Na, I better write the number, you guys will be confused. We have Na plus FeBr3, okay? And it's going to become something else. We don't really care. But what's important is, will sodium push out iron? That's the question we're really asking here. Is sodium going to displace iron? And again, look on your activity series at home. You've got the green sheet. Just look and see, is it high enough? And what we see is on the activity series, okay, which I can look at on my paper. Maybe you guys can see it. Sodium is up here where my thumb is. Iron is way down here. So yes, sodium is strong enough to push iron out. So the answer number 15, yes. Yes, this reaction will occur. Sodium will displace iron. And the reason why is based on the activity series. The activity series is all based on reactivity. So basically what we have to ask is sodium more reactive than iron? I'd say so. Next, number 16. HBr plus Fe, okay? Now what we got to say is, all right, is iron going to displace the hydrogen? Now this one's a little tricky. This is one of the harder ones, but looking at the activity series, I can see that whenever you're talking about hydrogen, oops, I lost track where I was. Whenever you're looking at hydrogen, you'll need to say, will it replace hydrogen from cold water? So as I'm looking at my green sheet that's not green, I can see up here, it'll replace hydrogen from cold water. All of the ones in here will replace hydrogen from steam. All the ones here replace hydrogen from acids. And down here, just all of these react with oxygen. But iron is in the zone that says it will replace hydrogen from steam, and it's also within the zone that replaces hydrogen from acids. Okay? Hold on one second, Ty, and I'll answer that. So this is an acid. The reason I know that is, as I just said, hydrogen is in front. Okay, ding, 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 warning signs all over the place. We are dealing with an acid. This will be hydrobromic acid. And iron will definitely replace it. It is in that section that will replace hydrogen from an acid. Okay, so yes, this is going to take place. So Ty, the reason I always look at the first part, you can look at the second part, only if you're concerned and you're like, well, what's replacing what? Like if you were looking at this and you weren't sure, like only looking at the front part, like is iron going to replace hydrogen or is iron going to replace bromine? Then you can look at the second part, but otherwise I always like to look at the first part and figure out like, oh, well, iron's going to replace hydrogen. Will they or won't they? Next one, number 17, and I am moving as quick as I can. I know you guys have other questions. So looking at number 17, I'm trying to knock out two birds with one stone here because a lot of you guys had questions about predicting products because you missed the stream from last week. So I'm trying to cover it a little bit, but I really want to talk about moles and stuff. Moles and stuff. By the way, why does that BR have a 2 right there? I got to get a sip of tea, so that's why I'm asking the question. Why does that BR have a 2 right there? That's what I'm waiting for you all to type rapidly on your computer. That was good. I'm going to need more of that. Pinkelbroth, yes. Brinkelhoff, yes. So remember, all your Brinkelhoff elements, whenever they are by themselves, okay, whenever they're by themselves, you got to have that little 2 there. All right, great job, guys. So we need to ask the question then, what is trying to replace what? And Ty, like you said, if you want to look at the second part of the reaction, I can see that Na, okay, took the place of Cl. So if we're curious, or sorry, Br took the place of Na. Nope, Br took the place of Cl. Now I've got myself all confused. But by looking at it, I can see that this is what we're trying to analyze. Because I can see what took place of what. Bromine took the place of chlorine. And so we're saying, oh, well, is that going to happen? Once again, look at your activity series. And by the way, both of these are not metals. They are halogens. So we have a special activity series that is just for halogens right here. And we can see that Cl is above Br. Br is not above Cl. And so no, this is not going to happen. Bromine is not as reactive as chlorine. And so because of that, it will not take its place. All right, taking a look at number 18. All of these, it says using solubility rules, determine if any of the products are only what are on the right side of the equation. I could care less about the left side of the equation. You only look at products. Determine if any of the products in the following chemical equations will form a precipitate in solution. Remember, guys, a precipitate is a solid that will not dissolve. Okay, so we're looking for the solids. If yes, list the product that will form precipitate in the blank. Okay, so again, only interested in product, so I could care less in number 18 that I have calcium hydroxide and hydrofluoric acid. All I care about is on the right side of the arrow, I now have HOH, which is a trap, by the way, plus CaF2, which is also kind of weird. HOH is just another way of saying, look, 1, 2 H's, 1 O, gee, it's H2O. And hopefully you guys know that at room temperature, H2O is a liquid. So you can put a little L there. So is that the precipitate? No, it's not, because it's literally just liquid. Next, we have calcium fluoride. So now I actually have to do something. So look, the way that I do it, and I hope you guys are doing this at home, is whenever I'm looking at solubility rules over here, we have two columns. It's either going to be soluble, which means it will dissolve, or it's going to be insoluble, which means it's not going to dissolve. It's still going to be a solid at room temperature. So what I like to do is when I'm looking at the list, I say, okay, well, I'm looking for fluorides. Okay, we have a fluoride. There's nothing about calcium. No calcides. That's not a thing. But we have fluorides, and I can see, oh, all fluorides are soluble. Okay, all fluorides are soluble except group 2. I'll say that again. All fluorides are soluble except group 2. And calcium is in group 2. So even though Drew seems to think that it's aqueous, this is actually going to be a solid. Okay? So use your thumb, use whatever you need to do, but that's how I do it in my head. I say, okay, all fluorides are soluble except when they're group 2, and then if they're group 2, they're insoluble. Insoluble means it's a solid. And so what's our precipitate? Calcium fluoride. So that is what you'd write in the blank. Okay, that's what I'd write in the blank. Okay, moving right along. Let's take a look at number 19. Let's take a look at number 19. All right. Number 19. Wow, that was great. We have some stuff, which again, I don't really care. I'm only interested in the products because that's what the question's asking about. For APO42. All right. So once again, we need to figure out what all this stuff is. No, H2O is not going to be aqueous. It's just going to be a liquid. Aqueous means dissolved in water. You can't dissolve water in water. And so we just say it's liquid. That's all. Okay. So aqueous means like salt. Salt, for instance, table salt. You can put that in water and it'll dissolve and go away. You pour water into water, you just have more water. So there's liquid and then there's aqueous. Okay, so now that we've got all this stuff set up, once again, we know this is going to be H2O liquid, but then we have this. This is where we got to use solubility rules. So once again, I look on my list, I can see that I have a phosphate here, and I can see it's in the insoluble. Okay, guys, this is not a good time to make fun of the way Mr. Nairn says water. Water. Exactly. So this is water, water. This is copper phosphate. And so once again, all phosphates are insoluble. They're insoluble, except group 1. Copper is not group 1, so it stays insoluble. So that means that we put an S there. Okay, and so what's our precipitate? Boom, there it is, precipitate. Moving on to number 20, right? Yeah, number 20. So I can see that my products are going to be sodium nitrate and silver carbonate. Silver 1 carbonate. All right, so here we go. We're all set up. Again, I'm looking and I'm saying, okay, NO3. Where does it say something about nitrates? There it is. All nitrates are soluble. Okay. Excuse me. Yeah, I know. Can you just? That's why I wanted you to go in the other room. All right. So anyway, how do you donate? There are no super chats in the stream. There are no super chats. So listen, focus, honey. Don't distract me. All nitrates are soluble. Okay. Period. And so if we know that's going to be soluble, what does that mean? It means it's going to be aqueous. Now that does not mean it's liquid. That means it dissolves in a liquid and goes away, okay? Then we have silver carbonate over here. Okay, we have silver carbonate. Look at my rules. I see all carbonates are insoluble, okay? All carbonates are insoluble except for group 1. Silver is not in group 1, so it's going to stay insoluble, okay? And so I don't say period weird. And so that means this is going to be the solid. That means this is going to be the precipitate. Okay. Quickly, I'm going to go get some water, and then we're going to continue. We're going to actually talk about moles to mass because I know that's what you guys are dying to hear about. If you have any questions about any of this stuff, I am ready to be done with it. There was a key that was posted for predicting products. If you didn't look at it, that's kind of your fault. But I posted a key to all the odd numbers on predicting products worksheet to try and help you guys. I've done this to try and help you guys. That's all I've got for predicting products. So I'm going to go get some water really quick. You guys type in any questions you have. Well, no, it doesn't. I would rather they knew one skill, which is just can you read solubility rules? If so, then great. I don't want them to have to memorize anything else. Don't let the haters tear you down. I plan not to. I'm only here for mole. I know. Can you go over the bell work? I'm going to. Okay, great. So if there's no questions, let me explain with this. Whenever we're talking about moles, it is easier to talk about eggs. And before you all start saying, oh, well, I wrote that in my notes, it didn't make any sense. Listen, it's not that bad. If I write a number, that's 27. I didn't say 27 what, okay? Yeah, I'm going to. I'm working. So look, 27, I'm just writing down a number. It has a value of 27. It could be 27 watermelons. I don't care what it is, okay? But if it's 27, can I multiply that by 1 and it's still equal to 27? Okay? You can multiply anything by 1 and it's still the same thing. That is crucial that you guys understand that. So even though I'm multiplying by 1, it's still going to be 27. Okay? So here's the thing. The egg example is good because we're going to talk about it here again in a second. Because if you think about it, 12 eggs is the same thing as 1 dozen. That's the same thing. So it's like saying, well, if 12 eggs is equal to 1 dozen, then isn't this just like saying 1? So if you multiply something by 12 over 1, you're still doing 1. So that means I could write it as 12 eggs over 1 dozen. That means I could write it as 1 dozen over 12 eggs. It's still equal to 1 because it's still the same thing. So listen, everything when we're doing conversions, because that's what I call it. There's a fancy name for it that'll confuse you. I always just call it conversions. Okay, but not a baker's dozen. That would be 13. Yes, that's right. But as long as you multiply by 1, it is the same value. It is always the same value. So what that means then, let's say I want to convert. And I'm like, I'm baking a cake. You know what? I am baking a big cake, all right, a real big cake. And somebody says, you know, I want to know how many eggs I want to know how many eggs I need if the recipe calls for 20 dozen. Okay? Stay with me. Okay, and I've got a calculator because I may actually have to do that because I'm having an off day. Where's my calculator? I put it back. Here it is. Yay, somebody texted me. All right, so here's what I'm going to do. Look, when I do 20 times 12, think about order of operations here, okay? If we're doing this, in fact, if I took the parentheses away, you guys would say, oh, well, you're going to do 20 times 12. You're going to do 20 divided by 1, okay? And yes, okay, apparently Drew's already ahead of me. It's 240. But here's the thing. This is going to equal 240 eggs, but look at what happened with the units. Remember what units are. Units are just way we describe things. Thank you, Drew. Stop spamming or I'm going to put you in timeout. So the dozen cancels. See, another way I could have written this is put it all over like this. I wouldn't, but you could do it like that. And so if I have dozen on top and I have dozen on bottom, guess what? That cancels. The units cancel. And so what that means is what I'm left with is eggs. So I could have done this the other way. If I wanted to say, oh, well, I want to, let's say I've got 312 eggs, and I want to know how many dozen that is. Okay, so we want to know how many dozen. Well, I'm not going to convert it the same way because I want to cancel eggs, and I want to be left with units of dozen. So what that means is I'm going to say, all right, well, wow, that train is really loud. Can you guys hear the train in the background? Because it's really loud. Eggs over eggs. That means that's going to cancel. But I want to have units of dozen. But remember, I'm sorry, yes, the train is really bad. It'll go away in a second. I'm lucky enough to live near the airport and next to a train track and pretty close to a highway, so I hear all the noises. So, eggs, dozen. But here's the thing. Even though I'm writing it like this now, 1 over 12, 12 over 1, that is still equal to multiplying by 1. Okay? Okay? And so what that means is whether I'm multiplying by 12 over 1 or 1 over 12, what's important is I want those units to cancel. So if I have eggs up here and I have eggs down there, those cancel out. So look, I'm left with dozen. So what's 312 divided by 12? Let's find out. I have a calculator now, and I'm going to beat Drew. 312 divided by 12 is 26. I beat you, Drew. So that means it's 12 dozen. And so it's all about, okay, making sure units cancel. So look, if you've got your notes in front of you, I want you to write this down. Because whether you're going from eggs to dozen or dozen to eggs, if you're going from moles to mass or mass to moles, you're always going to use this same formula. And I want you to write it big in your notebook. Okay? Whatever your units are that you're going from, okay? Whatever units you're going from, they are always going to go at the bottom of your conversion factor. Okay? This is called a conversion factor. You'll hear me say it a lot. And so I want to color code a little bit. You guys know me. I got a color code. So whatever you're going from is going to go on the bottom. And then whatever you're going to, okay? Like if you're trying to go to something, like maybe you're trying to get to eggs, okay? If you're trying to go to eggs, put 2 over here. Those are the units that go on top. Because when you set it up this way, what that allows you to do every time is those units that you're going from are always going to cancel. Those units you're going to are always what you're going to be left with. They will not get canceled. But what's important is always make sure the amount, okay, that you're putting in the conversion factor still got to be equal to 1. 12 dozen is equal to, 12 eggs is equal to 1 dozen and vice versa. And so that's how you use that. But you end up getting a number, okay, over here on the other side, and that's going to be your 2. So one other thing, unless there are any questions with this, I'm going to take a sip of water. Water. Okay, I want to show you one other thing, which is about mass numbers on the periodic table. because it's really important. I sent it in an email to a student earlier. I'm so depressed. The stream has lost 5 people. I hope they tune in tomorrow. I hope they watch it later. All right, so no questions about this, but have that written somewhere in your notes because it's useful. It's going to be useful for y'all. So here's the thing. If I asked you guys right now what the mass number was for oxygen, you could probably get your periodic table and say oxygen, oh, it's 16. But then I would ask you, 16 what? I am going to the bell work, Drew. I'm going as fast as I can. So 16.00 what? We used to say AMU. 16 AMU means atomic mass units. And the reason that was important is we'd say, oh, well, this 16 really just means 8 protons plus 8 neutrons. That is all still true. But now, instead of saying AMU, we're actually going to give it a new value, which is grams per mole. Grams per mole. And what that means is, in 1 mole of a substance, remember, 12 eggs are in a dozen. Okay, a mole means something. Okay, see again, and I don't know why you would want to finish it later. So grams per mole is a new meaning to it. Now, per. This is something that people do not understand. I can tell you grams per mole all day, but you need to understand what per means. And it reminds me of a YouTube video I saw years and years ago where there was a husband and a wife going on a trip. And the husband, was basically trying to pick on her. She had been sleeping in the car. And so the husband was picking on her. He said, okay, honey, we're going to try this again. We're going 60 miles per hour. So if we're going 60 miles per hour, how far are we going to go in 1 hour? And she said, I don't know. Please leave me alone. We're on vacation. I'm not here to do math. And he said, no, just listen. If we're going 60 miles per hour, how far are we going to go in 1 hour? And she said, I don't know. If you don't shut up, I'm going to punch you. Like she got really angry, like she'd been woken up or something. So what's important, okay, is that per means for every one. So if you think about 60 miles per hour, what that means is there's 60 miles in 1 hour. So if you're going 60 miles per hour, that means you're going to go 60 miles in 1 hour. So if you think about this in terms of chemistry, what that means is 16.00 grams per mole means 1 mole. So what that means is you have 16.00 grams of what? Oxygen. 16.00 grams of oxygen in 1 mole of oxygen. Okay? And that's what that means. Now, by now, you guys are probably asking, because this is the same thing. This is a 1 relationship. That's like multiplying by 1. Okay? 16.0 grams is equal to 1 mole of oxygen. Okay, so keep that in your head. So another thing I want to talk about is what that mole means. Usually written as MOLE, but usually I'll just shorten to MOL. That's the same thing as a dozen. How many eggs are in a dozen? 12. How many molecules are in a mole? This many. And this is called Avogadro's number. Did he say avocado? No, I did not. Avogadro's number, okay, is basically Avogadro identifying, that's a capital A, identifying and saying, look, when we're dealing with atoms, because you guys know atoms are really, 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 really small, okay? When you're dealing with atoms that are very small, it's inconvenient to say, okay, I've got 3 atoms over here and 3 atoms over here. So instead what they did, just like the eggs, it'd be annoying to go to the grocery store and say, I want 2 eggs. They're going to say, no, you can't do that. Get a dozen. If you're dealing with molecules or atoms, see, that's the thing. It could be molecules. It could be atoms, okay? But when you're dealing with something that's small, you don't want individual ones. You want an amount of something. And that's why we're going to use a mole. So 1 mole is equal to that. Still a 1-to-1 relationship. Okay, we got all that stuff out of the way. Let's take a look at the bell work, because I know that's what you guys have been waiting for. Don't forget to like, comment, and subscribe. And just remember that this video is brought to you by audible.com. Audible.com. There's like over 1 million different titles that you can read or listen to. Sorry, this is what they do in YouTube videos all the time. All right, so here's what we're going to do. Perform the following conversion type problems. We are now on the bell work, starting with problem number 1. Okay? So It says, perform the following conversion type problems. And so it says, all right, I've got 0.25 grams of Kr, and I want to find out how many moles of Kr is that. Okay? This is a very common problem. Okay, sorry, I needed a bell sound. I didn't have it. Sorry. I would have slammed the door at the bell, I promise. But we're trying to get to moles, we have grams. And once again, I just told you that the number on the periodic table, that atomic number, here, I'm going to see. Can you guys see this? It's right there above my finger. Wow. As you can see, my finger's still a little screwed up. That's kind of gross. But anyway, the number right here below krypton that the camera's not zooming on is the mass number. And so what that tells us is, again, krypton, it is 83.80. Now remember, that is grams per mole. Am I looking at the same problem you are? Anyway, 83.80, but that means grams per mole. Remember, per just means 1. Now remember, if we are trying to cancel out a unit, which in this case we're trying to get rid of grams, that is always going to go on the bottom. Remember, okay, whatever you're going from, okay, that's going to go on the bottom. Whatever you're going to, that's going to go on the top. So even though we're going to be multiplying by 1 here in a second, it's important that you flip-flop and get everything where you need it to be. Okay? So what I'm going to do is I'm going to write my conversion factor, but I'm going to write it this way. I'm going to put 83.80 grams on the bottom. I'm going to put 1 mole on top. The reason that's important is because, look, I want to get units of moles, okay? I want to end up with units of moles, and I want to get rid of units of grams. And honestly, if I were doing this really correctly, I would specifically say I'm dealing with moles of krypton, I'm dealing with grams of krypton. Be specific so you guys don't get confused. So what that means is I'm going to say, oh, well, I've got 0.25. Hey, look, the grams cancel. It's almost like I planned it. Hey, look, I'm left with moles of krypton right here. So what you guys will be putting in your calculator, and I hope you would, is I would say, okay, well, I'm doing 0.25 times 1. You don't have to do that. Enter, and then you're going to divide by 83.80. Wow, what a good 8. That looks fantastic. Look at that. And so when you do that in your calculator, now that'll give us a value. So I'm going to put it in my calculator because Drew's asleep at the wheel. My calculator on there. So 0.25 divided by 83.80, and I get 0.298. Let's just call it 298. Okay. Now, here's the thing. If I told you I've got 1 egg, how much of a dozen is that? You would probably say, oh, it's 0.00 something, because it's not a lot. 1 egg is not much in terms of a dozen. Well, look, I just told you 1 mole of krypton is going to have a mass of 83.80. So that's a really small amount of that. That's like less than a piece of an egg in a dozen. So what I'm saying is 0.25 grams, that's not much compared to 83.80. That's why this number is so small. That's why that's so small. Okay, we're going to do number 2. Unless you guys have questions, but we're going to look at number 2. I should have sponsored the video from Smithfield's Chicken and Barbecue. It is delicious. If you guys ever find yourself going down on the eastern part of the state, go to Smithfield's Chicken and Barbecue, also known as SCNB. It is delicious. All right, I'm going to keep that up there because that's going to be important. I'm going to use it on every single one of these. Number 2. Number 2, we have 0.333 moles of CaCl2. Oh no, what are we going to do? And we want to find out how many grams of CaCl2 it is. Now, don't panic, okay? Moe's Barbecue. Don't panic. We're dealing with a compound now, but we can still find out what its molar mass is. By the way, that's what that number is called. We used to call it atomic mass. Okay, so like for the last one, 83.80. If I wrote it in AMU, I would probably call this an atomic mass or the mass number. Okay, atomic mass number. But now we're getting to a point where we're saying, no. 83.80 grams per mole, okay? This is just going to be the molar mass. Here's why. Grams, that's your unit for mass. Don't ever say it's a unit for weight. It's not. Weight is pounds or something. Gram is mass, moles is molar, so molar mass is what we're dealing with now. So what that means then is I want to know, what is the total molar mass for CaCl2? What is the total molar mass? Well, let's look at what it's got. How many calciums does it have? Well, I can see it has 1. It's not written, but I know it only has 1 calcium. So I look and say, well, what's the molar mass for calcium? Where is it? 40.08. Grams per mole. Grams per mole. And then I want to say, well, how many CLs do I have? Well, I got 2. And each CL is going to be 35.45. How many did I just say we had? 2. So I'm going to multiply that by 2. So here's what we're doing. I add all this up. Okay. And I'm going to say, all right, well, I've got 40.08 plus 35.45, but I'm multiplying it by 2. In fact, you can maybe see in my calculator. I multiplied the 35.45 by 2, and now I'm entering it, and I get 110.98. Now let's talk about what that value means. What are my units going to be? Well, I just added up some grams per mole, so it's still going to be grams per mole. But that's not the grams per mole for calcium. That's not the grams per mole for chlorine. That's the grams per mole for calcium chloride. That's the whole thing. So whenever you're dealing with a compound, you add the molar masses all together. And if there's more than one, you count that one twice. So if we were doing H2O, you'd count oxygen once, and you'd say, well, oxygen has a molar mass of 16. But if there's 2 hydrogens, I'd say, well, hydrogen's 1 each, 1.008 each, times 2, and it ends up being 18.016 is the molar mass of H2O. Now, this was a big step. Please make sure you don't have any questions before I keep going. I'm going to give you a second because I need some more water. My throat's getting sore. I'm a quarantine teacher yelling at a computer right now. So here's what we're going to do. Now that we've done this step, I'm looking at the units. I want to get rid of moles. I'm going from moles, so I want to put moles at the bottom of my fraction. Oops, make it a little bit smaller. And so I say, well, I know this is equal to 1 mole, so I'm going to put 1 mole of what? Well, CaCl2, 1 mole CaCl2. And if I want to know, well, I want to get 2 grams, so I'm going to put that in the top. Look, 110.98 grams. 110.98 grams of calcium chloride is equal to 1 mole of calcium chloride. So I say, well, I'm going to put 110.98 grams CaCl2 up here. And then look at my units. Moles of calcium chloride cancels. Moles of calcium chloride cancels. And look what I'm left with. Grams of calcium chloride. So when I do this math on my calculator, I'm going to start with 0.333 times 110.98. Because look, we're multiplying these two. Equals divided by 1. I'm not going to do that. So what I end up getting, is 36.96 grams of calcium chloride. And yes, Brianna, what we do, I don't want to divide by 3. Hold on 1 second, Drew. Brianna, yeah, that number is what you get when you add everything together. So whenever you're dealing with compounds, you have to add everything up so that you're accounting for the total mass. Because like if we had just used 40.08, that would have been way too small, because 40.08 only applies to the calcium part of this formula, calcium chloride. If I had only used the 35.45, that only would have counted for the chloride part. But when I add all of it together and multiply by 2, because as you can see, I have 2 chlorines there. When you add all of it up, then you get the total mass, because I'm dealing with one big molecule now. Hopefully that makes sense, that calcium chloride would weigh or have a mass that's a lot bigger than just calcium. Calcium chloride should have a mass bigger than just chloride. That's why we add everything up all together. Okay, that's why we add it all together. It's not the answer. This is the answer, but that's how you do that. Okay, let me erase this. Look at the next one. Honestly, number 3 no, it's not even. Number 3 is weird. The 36.96. Oh, so what I typed in my calculator, Ty, look, 0.333 times 110, because they're on the same level. Here, look, I'll carry this line on out. See? 0.333 times 110, enter on your calculator, divide by 1, gives you 36.96. Check it in your calculator, make sure you get the number we're getting, okay? And don't worry, we're going to do number 3 next. Number 3 is kind of funky. Number 3 is kind of funky. And honestly, that comes from a time last semester I taught it in a slightly different order, where I talked about gases first, and then I talked about this, which was stupid, so that's why I'm not doing it. But I'll explain number 3. It's going to be great. All right, I'm going to erase. And again, if you feel like I'm going too quick, I'm going to post this later. As soon as it's done live streaming, it'll buffer and put it all together. And then you guys can go back and like pause the screen and get what you need, replay it if you want to hear my explanation again. That's the power of YouTube. At least I hope that's what works. All right, I'm going to keep my to from up there. Okay, and we're going to look at number 3. Number 3 is kind of weird, but it's not that bad. Number 3, first thing that we're doing, 11.5 liters. That was a bad screeching sound. But 11.5 liters of F2, okay, at STP. Now, this isn't something we've talked about yet, but don't worry. We're still going to multiply by 1. We're still going to multiply by 1, but I have to look somewhere. On the front page, well, come on now. On the front page of the green sheet, yes, I'm going to go to the practice worksheet next, Allie, I promise, before my voice completely dies on me. F in the chat for Naren's voice for yelling at his computer. So if we look on your green sheet, it says up here, volume of 1 mole of gas at STP. STP stands for standard temperature and pressure. At standard temperature and pressure, 1 mole of any gas is going to be 22.4 liters. So what we're saying then, 1 mole of a gas is equal to 22.4 liters. So that means if I wrote it this way, that's still multiplying by 1. Because if we're saying these are equal to one another, this is just like multiplying by 1. And remember, we can multiply anything by value 1, and we still end up getting the same number, kind of. We get the same value. 12 eggs is equal to 1 dozen. 1 mole of a gas is equal to 22.4. We can do whatever we want right here. Now, I wrote it that way for a reason. And I hope you guys at home can see why. Type it in the comments. I need to get some more water. Why did I write the conversion factor this way instead of putting 22.4 on top? Come on, guys. If you don't type, it's just me talking to myself with my wife dancing in the background. What are you doing? Oh, okay. She's listening to music. The 22.4, if you guys look on your reference tables, look on the very front. Hey, look, there's Avogadro's number. Okay. Yes, Elena, we're going to get rid of L in a second. That's exactly why. Good job. Gold star. But if you guys look on your chemistry reference tables on the very front, it says volume of 1 mole of any gas at STP, okay, is 22.4 liters. So it's just come from the reference tables, the almighty reference tables where everything is found, from solubility to activity to chemical predicting products recipes. It's all there. Okay, so what we end up getting then is just like you guys are saying, yep, from goes on bottom. Good job, Chase. From is what I'm going from. I'm trying to get rid of liters. So what I'm going from goes on the bottom. Remember, any gas. If I had told you, look, this would be exactly the same if I had said, you know what? It's oxygen gas. It's oxygen molecules. That means that in reality, you're dealing with something that looks more like that. You guys remember good old Lewis structures. But the thing is, there's still 1 mole of that. That means there are 6.022 times 10 to the 23rd of these molecules bouncing around. And at standard temperature and pressure, it's going to take up 22.4 liters. So 22.4 liters, that would be what, 11 2-liter drinks that you're hoarding in your house because you're afraid that the stores are going to run out of it. So anyway, that's why. So it doesn't matter if I'm dealing with O2. It doesn't matter if I'm dealing with H2O gas, water vapor. 1 mole of water vapor at standard temperature and pressure is going to take up how much space? Well, my reference table says volume of 1 mole of any gas, 22.4 liters. So even though you're seeing 2 F's, if I were dealing with H2O, if I were dealing with O2, if I were dealing with CH4, if all of these, sorry for my G's, if all of these are gases, they are all going to be 22.4 liters, all of them. And that's just gas stuff. That's a little weird. Part B of this problem, there is a part B. I don't know if you guys saw. Number 3, I want you to go to moles. And then after you go to moles, you're going to go to grams. Part B is a lot easier. So what I'm going to do then, as we can see, liters cancels. L is on top, L is on bottom. Those are going to cancel. And so then I'm going to end up getting moles. So I can type in my calculator. I can type in my calculator, and I get 11.5 divided by 22.4. And the reason I'm dividing is because, look, 11.5 times 1, enter, which is 11.5, divided by 22.4 gives me 0.513. Wow, that looks great. 0.513 what, y'all? Watermelons? You tell me. .513 what? Moles of what, Elena? Good. Moles of what? That's part of it. Moles of F2. Yes, moles of F2. Because look, that was still left over. So we have 0.513 moles of F2. But wait, there's more. Because the second part of the problem says, okay, now you got moles of F2. You're feeling like hot stuff. Well, now we need to find out how many grams is that going to be. And it's really not that bad. So look, I'm going to start with 0.513 over here. Always rewrite it, at least until you guys get better at this. So basically, I'm rewriting it down below because I want to get back to my from to thing. So I'm going to rewrite it. 0.513 moles F2. And I want to go to grams of fluorine, or sorry, fluoride, whatever you want to call it, fluorine gas. And I want to go to grams of fluorine gas from to. So when I'm writing my conversion factor, okay, I want to make sure that moles go on the bottom because that's what I'm going from. I want that to cancel. And whenever I'm going to needs to go on top. So I need to put grams up on top. Now, where am I going to get it? Where do you get grams? All of the numbers on the periodic table, all of those bottom numbers are grams per mole. But obviously, okay, now we're not dealing with just 1 fluorine. We have 2 fluorine. So as I look on here and I say, all right, well, fluorine, it's 19.0 grams per mole. But that is only for 1 fluoride. That's only for 1 fluorine. I have 2 fluorines. And if you're wondering, well, why is it 2? It's because it's Brinkelhoff. You guys know that. So we have a 2 there because of Brinkelhoff. So what that means then, if it's 19.00 grams per mole, I want to multiply this by 2 because of that right there. So what I end up getting is 38. Yeah. Yeah, 38. I don't want to look at the calculator. So when we multiply that by 2, we get 38.00 grams per mole. But now that's grams per mole of F2. That's what we want. That's what we want. Yeah, 38. So what I'm going to do, I'm going to plug that number in, this 38.00 grams, right here. Look, grams per mole. Grams per mole. Remember, per, P-E-R, is not just the sound a cat makes. It's also for every one. 38.0 grams for every 1 mole. So we end up doing this in my calculator. I'm going to do 0.513. In fact, it's still in the calculator. Times 38, because it's next to it. So times 38 divided by 1, which is a waste of my time. And I end up getting 19.5. Let's just call it 19.5 grams. Cannot believe it's raining again. So this one's really hard. This one was kind of tricky. I probably shouldn't have given it as a bell work, but I don't know. I figured I'd give it on there. Still good practice. Unless you guys have any questions about this, we are going to quickly, because time is running out and people are getting impatient. I've watched the number of students that are watching go down, 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 down over the last 30 minutes. So if you don't have any questions, we're going to jump into that moles to mass practice, and we'll do as many as you want to until everybody leaves. So I'm going to look on moles, or until Mr. Nairn gets hungry. All right, so moles to mass, molar mass practice. Okay, mole to mass practice. Okay, do we need to do 1 through 4, or at least do one of them? Should we do like number 1, number 2, number 3, number 4? Pick one. Quick. Whoever gets it in first, that's the one we're doing. I'm on moles to mass practice. 1, 2, 3, or 4. 4, got it. We're doing number 4. That's the hardest one. Good choice. So all we're talking about here, okay, all we're talking about here now as we go into the moles to mass practice, okay, looking at number 4, is it says calculate the molecular mass, also known as molar mass, for each of the following. For each of the following. And this is just like what we were doing in the bell work. We were doing it with calcium chloride. But basically, well, let's do number 4 real quick, and then maybe we'll do one more, because and then if we have time after we go over a couple of different ones, y'all that are asking for all of them, we'll come back. We'll come back and look at them. But let me get this first. So number 4, we have Ca3 PO4 2. Now this one is fantastic. Fantastic practice. Because the thing is, if I asked you guys right now, what's the molar mass for 1 calcium? Find it and type in the answer. With units, I'm asking you right now, what's the molar mass for 1 calcium, whatever? It's going to be 1 mole. What's the molar mass for 1 calcium? Find it. You should be looking on your green sheet, looking at a periodic table you got handy. Okay, Allie said 40.08 grams per mole, correct units and everything, gold star. But here's the thing. How many calciums do we have in this compound? Right here. Ooh. Type it. How many calciums do we have here? There it is, 3. So what I'm going to do is I'm going to multiply this by 3. Yes. And the reason being is I have 3 of them. But wait, I'm not going to do that yet, because I have more stuff in this compound than just calcium. Okay? That's okay. That's why I'm trying to be patient. That's why I have these awkward pauses, because I know the comments are taking a while. So look, phosphorus. Phosphorus, you might be thinking, oh, well, there's a 1 there. There's only 1. No. That 2 multiplies everything inside the blank. So even though there's a 2 here, that means 2 times 1. There are 2 phosphorus. So let's look at phosphorus next. So we did calcium. That's taken care of. Let's look at phosphorus. P. Molar mass for phosphorus. I look on here and I can see phosphorus, 30.97 grams per mole. And I just told you, There's 2 of them. 2 out here. Multiplies by the 1. But wait, there's more. Which one? Green, Tony? I'll try not to use it anymore. Okay, so what that means then, okay, now that I've got this, is I need to look at oxygen. Okay, because oxygen's in this mess too. And so if I look at oxygen, I'll have to look, I know 16.00 grams per mole. Again, I'm getting it from the periodic table. And so 16.00 grams per mole. But how many oxygens? 4 times 2. So we got 8 oxygens in one of these calcium phosphate molecules. So here's what you need to do in your calculator. Okay, when I do it, in fact, I'll try and write it somewhat neatly up at the top. Okay, what I type in my calculator is this right here: 3 times 40.08. Okay, plus 2 times, look at how I'm using my parentheses, 2 times 30.97 plus 8 times 16. And then I hit enter in my calculator. And so by doing that, that gives me the molar mass of everything, okay, individually. Okay, and so that's why I'm doing what I'm doing. Ooh, sorry, technical difficulties. So when we do all that stuff, then I'll type in my calculator really quick. I really hope you guys are trying too, and you're not just taking me at my word, because I might type it wrong in my calculator. So I hope you're trying this. And I get 310.18. Yeah, good job, Allie. Yep. So we get that value. Here we go. So the total then of this whole thing is 310.18 grams per mole of calcium phosphate. That's all. There you go. So there's problem number 4. Take a second to make sure you don't have any questions. Pick one more of 1 through 4, and then we're going to do one of the different ones. So pick 1 through 3. Pick 1 through 3. I got to get some water. Well, you can go get it and bring it here. Okay, wow, Drew. Thanks a lot for that. Okay, no, that's not it. I just had to go get some water. That's how you do these. I'm writing a lot of stuff right now. As you guys get better at it, that right there is all you're going to do in the calculator. It's going to be really quick, okay? Drew, do you really want to go over 3? Do you really want to go over number 3, or are you just typing all of them because you want to go over all of them? Because I really want to go over one of the other types. All 1 through 4 you do exactly the same way. All right, fine. Number 3, I'm going to go a little bit faster this time, so just make sure you're with me. Number 3, I have Na2, SO4. So once again, I have 3 different elements here, okay? Yeah, Allie, I'll do that. Let me go over an easy one first, and then I'll go look at 11 and 12. Okay, so Na2SO4. So we're down to 10 people now. People are dropping like flies. So 2 sodium, Na, molar mass. I look on here, and I see sodium 22.99. And I can also see I have 2 of them. That's what that right there means. So, oops, sorry, I didn't put units. I will get really mad at you guys if you skip units, so don't let me do it. There we go. 22.99 grams per mole times 2. That's sodium. Next, let's take a look at sulfur. Okay, sulfur. How many sulfurs do I have? 32.07. And if you don't know where I'm getting these numbers from, I'm looking at the periodic table. It's the mass number, okay? But now we call it molar mass. It's the same number, different usage. So guys, how many sulfurs do I have? I was hoping you'd type something by now. The lag's not that bad. Okay, apparently it is. There's one. Because look, there's a 1 written there. That 4 is not outside of parentheses. And so because that 4 is not outside of parentheses, the 4 is only multiplied by the O. So that means there's only one S there. Okay? There we go. Now people are getting it. No, it's not 4. But there are 4 oxygens. So I now look at oxygen. I really want to use something else. Here we go. Look at oxygen. And I can see, look, oxygen, 16.00 grams per mole. Is that hard to read? You have to let me know. And so there are 4 of them. So in my calculator, I will read to you guys what I'm typing. See, Tony, you can watch the rest later if you want to. So I'll look and I'll say, all right, well, I'm going to do parentheses, 2 times 22.99 plus 1, if you want to, 1 times 32.07 plus 4 times 16. Get it all, and I get 142.05. That's what I got for all of this. Now, once again, it is crucial that you guys understand the meaning for that. So when I get 142.05, when I get 142.05, that means 142.05 grams in 1 mole of that sodium sulfate. That's what that means. Okay. All the rest of 1 through 4 are exactly the same, so I'm not going to waste any more time on it. Okay. I'm not going to waste any more time on it. If you have more questions later, maybe. Let's take a look at number 5. Yeah. Let's look at number 5 real quick. All right. Again, if you want to look at this later, you can by pausing the video after we're done streaming. Let's look at, oh no, I messed up my thing. Need to rewrite it anyway. Wow, that looks terrible. Okay. What did I say? Number 5. Okay, fine. We'll do number 6. I don't care. Number 6. Number 6, it says if you have 180 grams, I'm always going to write what they give me. So if I have 180 grams of CaOH, 2, how many moles do you have? Okay, so I've got this. I want to know how many moles of CaOH, 2, there we go, do I have? So look, I'm going from grams, I'm going to moles. So when I make my conversion factor, okay, which goes in here, I need to make sure I have grams on the bottom. What I'm going from always goes in the bottom. So I'll put grams down here on the bottom. I'm going to put moles up here on top. Okay, but now we need to know where these numbers come from. And once again, when we're dealing with a compound, I can't just look at calcium. I can't just look at oxygen or just look at hydrogen. I have to add them all up. So what I would do then is I would say, all right, well, where's my, sure, he's blue. That's all right. Well, calcium has a molar mass of 40.08. There's only one of them. Plus oxygen, there's 2 of those. Plus hydrogen, there's 2 of those. Wow, hold on. And so look, calcium, oxygen, hydrogen, 2 hydrogen, 2 oxygen, 1 calcium, and I'm going to put all that in the calculator. And I get 74.09. Let's just make it 74.1. Okay. But again, that means 74.1 grams per mole. Now listen, If that's grams per mole, I don't want grams per mole. I want moles per gram. 74.1 is the gram amount. Per, as I've told y'all, per mole means 1 mole. So I'm going to put 1 mole up there on top. Okay? And so now that I've got that in my calculator, what I'm now going to do is I'm going to say, all right, well, 180 times 1 divided by 74. And I get 2.43. And I ran out of space to write it, but I'll write it up here. 2.43 moles of calcium hydroxide. How do I know that I've got moles? Well, look, I had grams of calcium hydroxide, and then I divided by grams of calcium hydroxide, and I ended up with moles over here. So that is how you get your answer. That's problem number 6. There we go, just a little bit. So that's how you do number 6. And that is honestly how a lot of these work. If you're ever going from grams to mole or moles to grams, you use what's on the periodic table. And if you're dealing with compounds, you have to add it all up, just like I did down here. You got 1 calcium, only add it once. You have 2 oxygen, add it twice. You have 2 hydrogen, add it twice. But you have to deal with the whole mass. You can't just deal with individual pieces. Okay? All right, I'm going to look at number 11 next. I'm jumping ahead. Okay? So look at number 11. And time is running out. I really didn't want the stream to reach 2 hours because what I'm afraid is going to happen is people are going to see like 2 hours. I'm not watching that because you know how you guys talk. All right, so looking at number 11. Ah, yes. Now here's what's important. Okay, it says remember that at STP, which means standard temperature pressure, 1 mole of gas occupies a volume of 22.4 regardless of whatever type of gas you have. So what that means then, 22.4 liters equals 1 mole of a gas. Okay, so you got to know that. So for number 11, it says at STP, O2 gas occupies a volume of 19.2 liters. Always start by writing down what they give you. So I'm going to start, well, I got 19.2 liters. Liters of what? Oh, it says O2. 19.2 liters of O2. Okay? Drew, I'm glad that you're so confident, but what I'm saying is a lot of students are going to look and they're going to be like, oh, I don't have time for that. I'm not watching that. And then they're going to complain to me. Yeah, I thought about doing timestamps too. And that's why I've been doing this up here so that hopefully people can scroll through and find the part that we're doing. Anyway, 19.2 liters of oxygen. And we're trying to find out how many moles of O2. So, okay, I'll start. Well, I want to get moles of O2 over here. Always start by doing this when you're doing these conversion problems, because look, this is what I'm going to do next. Whatever I'm going from needs to go on the bottom. So I'm going to put liters on the bottom. Okay, here we go. Put a line there. I want liters of oxygen to go away. And I want to get to moles of oxygen because I'm trying to go 2 moles. So now what I'm going to do is I'm going to say, well, how do I know these values? It says it in the instructions on the worksheet. It says it on your green sheet if you know where to look. At standard temperature and pressure. In fact, I can write it over here. 22.4 liters is equal to 1 mole. Always, forever, period. And so what I'm going to type in my calculator then is I'm going to say, all right, 19.2 times 1. Obviously, you don't have to do that. You guys can do math. But it helps a lot of students know that you always do this times this, enter, divided by this. And we get 0.857. Done with part A. I think that was part A. Yep, that's it. That's how you do part A. Questions so far? I'll give you 10 seconds. Yes, this is from the periodic table, the 22.4 value. Elena, I'm trying to understand. So STP is just because, look, I'm looking on the very front page of the chemistry reference table. Okay, So on the very front page of the chemistry reference table, right there, okay, where my finger's pointing, I know you guys can't read it, but it says volume of 1 mole of gas, okay, at STP. And STP just means standard temperature pressure. We'll learn more about that later, but for right now, just trust me. 1 mole equals 22.4. 22.4 liters equals 1 mole of a gas. All right. So now that we've done this, let's look at part B. It says, how many grams of O2 gas is this? Well, that's not too bad. That's really not too bad. So let's say, all right, well, B, how many grams? Look at what we have from the last problem. We got 0.857 moles of oxygen. That's going to be really useful. So I'm going to start with that. And I want to find out how many grams of oxygen it is. So I'm going to put grams of O2 over here. Always start by setting it up like that. And then I know I'm going to need a conversion. Okay. And again, I'm going from moles. So I'm going to put moles of O2 down here on the bottom. I'm going 2 grams. So I'm going to put grams of O2 up here on top. Now remember, grams per mole always comes from the periodic table. All those molar masses are on there. And for oxygen is 16. Be careful. How many oxygens do we have here? We have 2. It's O2. It's not just O. That'd be ridiculous. It's Brinkelhoff. You have to have 2. So if there's 2, it's not going to be 16. So this is from the periodic table. We know we have 16.00 grams per mole for 1 oxygen, but we have to multiply the, oh, that looks like I'm dividing. We have to multiply this by 2. So we end up getting 32 grams per mole of O2. So now what I'm going to put in my calculator, so I'm going to say, all right, well, I got 0.857. That's 875. Let's try it again. 0.857 times 32. Enter. I get 27.4. I'm going to divide by 1 just because we can. And so I end up getting 27.4 grams of glue. Okay, 27.4 grams. And look, moles cancels, and I'm left with grams. And that is how we end up getting this answer over here. Questions before we move on to the next part? We're going to look at number 12 here in a second. Any questions? It's all doing the same thing, guys. This right here. It's all doing the same thing. It's just what are they giving you? Okay. I'm going to take a look at number 12 then, because I'm not seeing anybody typing anything, and time is running out. Okay, let's look at number 12. Which is also, it's kind of a two-parter. Part C is really not that bad, but we're going to look at it anyway. All right, so taking a look at number 11, it says, 12, okay? At STP, an unknown gas occupies 1.01 liters. How many moles of the gas is this? Once again, I'm always going to start with the number they give me. So I'm going to start by saying, all right, I got 1.01 liters. Of what? We don't know. It's some gas. But again, all gases at standard temperature and pressure take up how much space? Everyone at home is hopefully saying the number I'm looking for. But we're looking for moles. So I'm going to put moles over here. Unknown gas, doesn't matter. It's still a gas. I'm going from liters. I want to put liters on the bottom. I'm going 2 moles. I want to put moles on top. And so as you guys are hopefully saying, good job, Allie, 22.4 liters is equal to 1 mole. Okay? 22.4 liters is equal to 1 mole of any gas, unknown or otherwise. So in my calculator then, I'm going to do 1.01, excuse me, not 101, 1.01 times 1, okay, whatever, divided by 22.4, and I get 0.045 moles of something. Moles of something. Now, why is that such a small number? Why is that such a small number? Anybody? Is 1 egg very much of a dozen? No. Is 1 liter very much of 1 mole of a gas? No, because 1 mole of a gas should be 22.4. So 1 is very, very little compared to 22.4, which is what's actually in a mole. Okay, so that's why. All right, let's take a look at B real quick. If you have questions, be typing them. I'm reading. I'm keeping a close eye on it. All right, if the gas has a mass of 0.90 grams, what is the molar mass of this substance? And the key here is you got to look at the units. Okay, units for molar mass are always, okay, molar mass is always going to be grams, okay, per mole. So it's going to be grams per mole. So what that means then is I'm going to say, well, if it's 0.90 grams, this one's kind of weird. This one's a little unusual for us. But if it's 0.90 grams, and I know that that's going to be 0.045 moles of something, look at what I just did with my units. I've got grams divided by moles. So what I'm going to do then, I'm going to say, well, take my, oop, yeah, that's right. And they give us 0.9, yeah. So I'm going to do 0.9 from the problem, grams, divided by 0.045 moles, and I end up getting 20. 20 what? Look at my units. Grams divided by moles. So there's the molar mass of the substance. That's the molar mass. And then we get to part C, which is basically just saying, okay, what is this thing? If it's 20 grams per mole, what is this thing? Well, let's look. Let's look at the periodic table. Remember, all of these things that we used to just call atomic mass or the mass number is the same thing as molar mass now. And as some of you have already seen, it is going to be neon. 20.18, that's pretty darn close to 20. Okay, and so yeah, this is going to be neon. Okay, questions? There's only 6 of you left. I can do whatever you want me to do. Until my wife says I have to get off and eat dinner because she's hungry and I'm kind of hungry too, if I'm honest. I do thank you guys for sticking with me this long. I hope this is helpful. I'm doing the best I can. Number 8, the ocho. All right, let's take a look at it. What is the number of moles present in a sample of strontium carbonate that has a mass of 48.7 grams? Notice how I just set that problem up. Because a lot of these problems are all exactly the same way, where you read a problem and you say, okay, what is the number of moles? Okay, I'm trying to find number of moles. That's what I'm trying to get to, moles of strontium carbonate. And then they'll say, okay, well, it has a mass of 48.7. They're always going to give you something, and you're always trying to go somewhere else. You're always going from something. You're always trying to go to something else. So always start by doing this. And then the next part's pretty easy, because then I'm going to say, okay, well, I know I'm going to need a conversion. Okay, I'm gonna need a conversion factor. I know that I'm going from grams, so I'm going to put grams down here on the bottom, grams of strontium carbonate. And I know I'm going to moles, so I'm going to put moles up here, moles strontium carbonate. And now you've got to get this information. It's on the periodic table. Whenever you're dealing with grams to moles or moles to grams, periodic table. I'm going to say that again. Whenever you're going from grams to moles or moles to grams, where do you go? The periodic table. That's correct, students that are through the internet. And so you're always going to use this in some shape or form, even though it flips back and forth. You get that gram number from the periodic table. Now, obviously for this, it's not going to be so cut and dry. We're not dealing with a single element. We're dealing with Strontium, carbon, and oxygen. So what I'm going to do is I'm going to start strontium. That's all right. Strontium. I'm not going to say it that way. It is strontium. Look it up. How do you say it?
Strontium.
Okay. Strontium is 87.62. How many? Just one. Okay, so here's my strontium. Next, I'm going to have carbon. Carbon is 12.01. How many do I have? I still just have one, so there's my carbon, plus oxygen. Oxygen is 16.00. I know that because I've seen it 1,000 times, but there are 3 of them. There are 3 of them. So in my calculator then, I'm going to type all this stuff up. 87.62 plus 12.01 plus parentheses. I use parentheses. 3 times 16, close parentheses. Or you could just say 36 because you guys can do math. Allie got 147. I also got 147. I got 147.63. Not that it matters a whole lot. There we go. Yeah, I got 147.63. So what that means then, 147.63 grams per mole. But I want moles per gram. But it doesn't matter. Per just means 1. 147.63 grams per 1 mole. So that's going to be a 1. 147.63 is going to go right here. Okay. Sorry that my handwriting is so poor. I really think it is good practice. Everything that you see me write, okay, this is kind of extreme, what I'm doing over here in the corner. This is what I want to see for your work. Okay, Tess? So every time you're doing these problems, I want to see that conversion factor. Okay, that's pretty important. All right, so what I'm going to do in my calculator, 48.7 times 1, I'm not going to bother, divided by 147.63, and I get a number, 0.3, I'm just going to call it 0.33. Boom, there we go. Okay, that's it. That's number 8. Questions? Okay, I will do 1 more or 0 more. If you guys are satisfied and you're like, hey, this is a lot better, I think I'm ready to do some practice on my own, you feel free. But otherwise, I've been streaming for 2 hours and 7 minutes. And I've been drinking a lot of water. Okay, guys, let me know if you need any help. Please send me remind texts. Take care of yourself. If you need anything, you know where to find me. Okay? And I hope I am a little hungry. And if you guys need anything, just let me know if I can help you. Okay? See you guys. Take care.